Today, in section 2.5, we're going to learn about the measures of position. Our learning targets are: I will know how to find the first, second, and third quartiles of a data set, how to find the interquartile range of a data set, and how to present a data set graphically using a box and whisker plot. I will also know how to interpret other fractals such as percentages and how to find percentages for specific data entry. I will also determine and interpret the standard score, the z-score. Couple definitions first. A fractile. Fractals are the numbers that partition, divide, an ordered data set into equal parts. Quartiles approximately divide an ordered data set into 4 equal parts. The first quartile, quartile sub 1, is about 1/4 of the data fall on or below quartile 1. Second quartile, quartile sub 2, about 1/2 of the data fall on or below quartile 2. Quartile 2 is also the median of the data set. Third quartile, Q sub 3, about 3/4 of the data fall on or below quartile 3. So here's an example of finding quartiles. The number of nuclear power plants in the top 15 nuclear power producing countries in the world are listed. Find the first, second, and third quartiles of this data set. So the first thing you need to do is you need to rank order the data. Quartile 2 will be the median. Quartile 2 will be actually one of the data elements if there is an odd number of data set. If there are even number of data, then it's going to be the average of the two middle ones will be quartile 2. Now let's look at the lower half and the upper half. So the lower half has 7 numbers. The upper half has 7 numbers. So that means quartile 1 will be the middle of those 7 numbers, and quartile 3 will be the middle of those 7 numbers. So because the lower half is odd, quartile 1 is actually a data element. If the lower half was an even number of data, then it would be the average of the two middle ones. The same thing with quartile 3. So about 1/4 of the countries have 10 or less, 1/2 have 18 or less, and about 3/4 have 31 or less. Now let's talk about the interquartile range. The interquartile range is the difference between the third and the first quartiles. So you first need to calculate quartile 1, 2, and 3. Then you can use quartile 3 and quartile 1 to determine the interquartile range. It's Q3 minus Q1. In our example, quartile 1 is 10, quartile 2 is 18, quartile 3 is 31, so it's 31 minus 10, or 21. The number of power plants in the middle portion of the data, about 50%, at most are 21. Box and whisker plot. The box and whisker plot is an exploratory data analysis tool. It's a visual aid. It highlights important features of a data set. Requires 5 numbers, the 5-number summary. Remember that. When you're asked for the 5-number summary, you want these 5 things. You want the minimum entry, you want Q1, Q2, Q3, and you want the maximum entry. So you need to order the data from smallest to largest. So we're going to find the 5-number summary of the following data set. We're going to construct a horizontal scale that represents the range of the data. Then we're going to plot the 5 numbers. Then we're going to draw horizontal lines and vertical lines to make this box. All right, then we draw the whiskers from the box from Q1 out to minimum and Q3 up to the maximum. All right, so we have this information. We have minimum is 6, Q1 is 10, Q2 is 18, Q3 is 31, and the max is 104. So on a number line, we put all those dots, 6, 10, 18, 31, and 104. Then at 10, 18, and 31, draw a small vertical line through those dots. Then put a horizontal line on top and a horizontal line on the bottom, creating a box. Then from 10, go down to 6, draw your whisker, and then from 31, go up to 104 with another whisker, and you're done. Now the one thing I want to point out is, notice the whisker between 31 and 104 is quite long. This might tell you that it could be an outlier. All right? There are other types of fractals. Quartiles, like we just learned, Q1, Q2, Q3. Deciles, which are when you divide the data in 10 equal parts. Percentiles is when each data point is a percent of 100, so you divide the data into 100 equal parts, right? All right, so here's an example of percentile. The ogive represents the cumulative frequency distribution for the SAT test scores of a college-bound students in recent years. What test score represents 62%? So 62% is the vertical bar on this graph. So you go up the 62, you go over to the graph, you see where it intersects, then you go straight down to see what the score was. In this case, it's 1600. So that means 62% of all students had an SAT score of 1600 or less. Standard score, also called the Z-score. The standard score, the Z-score, represents the number of standard deviations a given value V falls from the mean U, mu. Notice it's mu, so this is for population. So the formula is the data value minus mu divided by the standard deviation. So here's an example. In 2009, Heath Ledger won the Oscar for Best Supporting Actor at age 29. That is the data point, that's X, for his role in the movie The Dark Knight. Penelope Cruz won the Oscar for Best Supporting Actress at age 34. That's a different X, for her role in Vicky Cristina Barcelona. The mean age of all Best Supporting Actors is 49.5 with a standard deviation of 13.8. The mean age of Best Supporting Actresses is 39.9. Those are the two mu's. You have a mu of 49.5 and you have a mu of 39.9 with a standard deviation of 14. So our two sigmas are 13.8 and 14.0. Find the Z-score corresponding to the ages of Ledger and Cruz. Then compare your results. So first we take his age, which was 29. You subtract it from mu, and you divide it by the standard deviation. And you get negative 1.49. That means it's 1.49 standard deviations below the mean. For Cruz, her age was 34. So 34 minus 39.9 divided by 14 is minus 0.42, which means her age was 0.42 standard deviations below the mean. What does this mean? All right, so when data falls in a bell curve, we can look at the standard deviations. So when z-scores fall between a -2 and 2, those are usual. That's about 95% of all the data that falls between those two standard deviations. When it's between -3 and 3, it's a little unusual, okay? It's significantly far away from the mean. And if it's more than -3 or 3, it's very unusual. Like someone who scored a perfect score on the SAT would most likely be a very unusual z-score. So both the z-scores fall between -2 and 2, so neither score would be considered unusual. Compared with other Best Supporting Actor winners, Heath Ledger was relatively younger, whereas the age of Penelope Cruz was only slightly younger than the average age of other Best Supporting Actress winners. All right. In summary, we found the first, second, third quartiles of a data set. We found how to find the interquartile range of a data set, and we looked how to interpret graphically using a box and whisker plot. We can interpret other fractals such as percentages, with the SAT example, and percentages for a specific data set. We also determined and interpreted the standard deviation, the standard score, which is the z-score.